Quick, thanks for the introduction, Mario. Um, as Mario said, I wrote a book on designing large language model applications, published by O'Reilly. It was up. Um, it, it has been out for the last few months now, and it's available on the O'Reilly platform. So today I wanted to speak about deep research systems, and there are so many different companies that have come up with this feature that they all have grown up to name deep research. So OpenAI was the um, one that came out with the first deep research system, and then you had Gemini deep research, and the Perplexity deep research. And there are so many other domain-specific deep research systems that still go by the name deep research. So, uh, what exactly do deep research systems do? I think we have to make a distinction between what is possible now using these systems, like given the very the stage of their infancy that they are in, versus what they can be in the future, and like what goals we have for what a deep research system can amount to be. So I would use this definition that I think gives a reasonable explanation of what a deep research system does, which is a system that takes an arbitrary number of retrieval and reasoning hops to resolve an information need in detail. Um, so there are two important components that have, and there is an interplay between them. That is retrieval, that is fetching data from various sources, and then using that to perform reasoning, and then doing that in an interleaved manner. So it's not just you retrieve and reason, but you need to interleave them in a manner such that new knowledge can be synthesized. The detail part is also a key feature of the deep research, which means that you are going through a massive set of documents and trying to make different types of connections between them. So I have been working on deep research systems at my company Hudson Labs for over a year now. And when I first started working on it, on building one for, and this is for the financial domain, I had what I would call a religious experience. The deep research system was able to provide me with this information, and I can talk about this. There is a company A, which is a pretty large company, and in an obscure web page, um, it says that company B is one of the suppliers of company A. And then there's this very obscure local newspaper from Mississippi. And that newspaper says that there was a hurricane and then it destroyed the manufacturing facilities that are based in a particular street. But it's the same street that company B is located in. And what the deep research system was able to deduce using these two very disparate sources of information was that, oh, company A is now going to face supply issues, supply chain issues, because company B manufacturing facilities have been uh, disrupted. Uh, and there is no web page or, information that puts those two things together and says that company is facing a potentially facing a supply shortage, but the deep research system was able to put two very distant documents, we would say, that are seemingly unconnected, put them together and came to the conclusion. And the world did not know, or it was not made public about company A getting supply chain issues until a few months later. So you can see the potential for something like this, where a system can go through uh, hundreds and thousands of different types of documents related to different topics and try to find connections between them. Uh, but uh, from this example, what you can see is that deep research is not just extended, glorified extended search. that is the way it is implemented in a lot of deep research systems now, where if you do a deep research query, it's just going to go through 100 web pages and then summarize the information for you. In order to get these second order connections, you don't just need search, you need reasoning. So that's why the interplay between reasoning and retrieval is very important. So um, now I'll like chronicle the um, experience that I had in building a deep research system at at my company. Um, and these are the basic components of a deep research system. So there's the retrieval system. So there's a retrieval system, and this is can be as complex as you want to be. Uh, the retrieval can be from just the web or any other data sources that you have access to. Then there is the reasoning system, and the reasoning system can be a model like uh, OpenAI's O1, O3 O series reasoning models or DeepSeek's R1, etc. Uh, and it can be specifically tuned towards deep research tasks, or you can use it out of the box, uh, depending on you know the type of queries that you expect to come. Then there is also the report generation system, which is once you have synthesized all the details, all the documents, done all your reasoning, you will have to generate a report, and the report may be sufficiently long enough, but there is a decision that needs to be done on what is interesting enough to go into the report versus not. And the report generation system is usually uh, a, a long context LLM that can not just generate the report at the very end, but stay in the loop throughout the deep research uh, workflow, building newer versions of the draft versions of the final report as the deep research carries on. And then there is the context orchestrator. So this is what a lot of people call as context engineering, ensuring that at any given point in time during the deep research workflow, that the model has the right context in the context window that allows it to make a decision, that allows it to make the best reasoning and so on. And then there is the depth and breadth balancer. This is something that's very critical for deep research systems to work. And the reason is that you can, if you don't have this, if you don't have a balance between depth and breadth, the deep research system can go into rabbit holes, or it can start veering into very um, unrelated documents that just don't have any uh, connection to the original query. So let's talk about each of these systems and see how they can be implemented. So the retrieval system, and I think by retrieval here we mean agentic retrieval, where the model is determining what to search, when to search, and how to search. Um, what to search for is important because initially the user just gives the user query, and the model should figure out at a given point in time it needs to be searched for X, uh, and then it also needs to know when exactly to search, because it's interleaved. Search and reasoning are interleaved, so needs to know that I need to stop searching and maybe I need to do some reasoning and generation. Uh, and then the how to search, it's usually it needs to know where it can search for. So if it's, for example, it's searching some relational databases, that it can generate appropriate SQL for it. Or if it's doing a web search, it should know to generate a API call to a search system, a web search API, for example. And so these should all be baked into the agentic search pipeline. The how do we get this done? And this is a little outside the focus of the talk, but you can use SFT and RL to bake these behaviors into the model that is doing the retrieval, the agentic retrieval. So when we talk about what to search for, uh, that's we call it the QA query generation module. That's part of the retrieval system, and there are many different ways that you can do this. So you can start with bottom-up versus top-down queries. So where top-down query is, you take what the user is asking and then drill down slowly, or uh, you can fetch uh, a bunch of topics related to the original query that's bottom-up, and then try to go breadth-wise. Uh, so far, I have found that at least for our use case, top-down queries work a lot better. Uh, the level of detail is supposed to be a hyperparameter. This is so that you can control uh, the basically control how much you want to search, how extensive the search should be, etc. And ideally, you would have a tightly coupled search system. What that means is the retrieval system and the reasoning system should there should be some feedback between them, so that uh, ideally they would be trained together. But otherwise, if not trained together, there should be some way for the retrieval system to provide feedback to the reasoning system and vice versa, so that they can help each other become better. So the retrieval pipeline uh, can be as extensive as you want to be, but some of the very, I guess, common steps would be to do a first step retrieval and then do a re-ranker, use a re-ranker to rank the most pertinent documents that you need during that particular phase. Um, there there's one important phase here in deep research is refine because of the problem with the context. When you are doing deep research, one of the biggest pain points is the hitting the context limit. Because if you're going through a lot of documents, that means you can't fit all the things that you are retrieving into the context window. So sometimes you just need to refine or summarize the document that you have retrieved so that it can fit into the context window. Uh, the other thing is the context orchestrator, and context orchestrator, as I said, is the one that um, does. So you can use this for things that the model is not already doing. So this is a scaffolding software. So for example, interleaving retrieval, reasoning, and generation can be done through the model. Maybe the model uses special tokens to say that it's now entering reasoning mode or retrieval mode or generation mode. But you can also do it via software by using some heuristics to figure out when to do retrieval and when to do reasoning, etc. So that's the trade-off between like internal versus external decisions. Internal is when the model itself is doing all of these, but you can also do it externally through an orchestrator that keeps um, you know that uses heuristics and other rules to determine when to perform one step versus another. So how do we, you know, what the other part that the orchestrator is going to do is to help with the what we call context engineering. So context engineering includes knowing that means we have to give the model at any given point of time all the information that it needs in its context so that it can do its job in the best way possible. So what does it need to know? It needs to know what the overall task is. It needs to know what kind of content has been searched through so far so that it's not going to repetitively go through the same thing. It knows how the content searched through relates to the task. And also it needs to know the current state of answer generation. Uh, so feeding these into the context window and keeping the swapping in and out information so that you don't uh, overshoot the context length. The maximum context length is a very tricky problem in the deep research system. And finally, the depth and breadth balancer. is a, uh, as I said, a very crucial um, component. And I saw that without this component, your deep research system will work, but it will not give you good results. It will go into these uh, very banal rabbit holes that bring forward nothing, or it just goes through a lot of irrelevant documents and never comes up with anything that's worthwhile. So the depth and breadth balance, again, you can do it intrinsically or externally. Uh, if you're doing it externally, you can have something like a threshold and a ceiling. You can say um, you can't go below depth 4. So that means uh, it's like a protection against going into rabbit holes. How do you define depth and breadth? Is it's something you can define through a prompt, and then ask the model to um, always keep track of the depth and breadth that it's doing while it's doing retrieval. That's one way you can do it. Uh, Breadth is basically for a given topic, how many different documents that are you going to see. And depth is, let's say you are searching about something, and then you search about a subtopic, and then you search about a subtopic, and so on. So that's how depth is measured. Obviously, depth and breadth both are more so depth than breadth is kind of subjective. So we allow the model to make a decision on when actually we have crossed a depth level. So I'll spend the remaining, you know, uh, part remaining time in my talk to talk about deep research evaluation strategy. Um, ac- as we have seen, a deep research system involves so many components, and evaluating all these uh, components that are so interwoven with each other is a very challenging task. So here are some strategies that I've been using at my company, uh, and one of them is to invent scenarios. So what does this mean? Um, so what I want to test is the thing that brought me a religious experience. To be fair, I just want to clarify. This is something that I could not replicate. So even like a year into working in the deep research system, I've never been able to get information that is as valuable as this one, because deep research systems are very hard to build, as we have seen. It involves so many components, and so many things can go wrong because of the inherent limitations in retrieval, in reasoning, in context length, and so on. So one way to um, you know evaluate them is to construct documents whose combination leads to emergent knowledge. So that means in this case, it's something like here where we have these two documents, and if we combine them together, then you get some new knowledge, and that's we call it emergent knowledge. The emergent knowledge is not explicitly stated in any single document, but it's synthesized from several documents. So what do we do here? We bury these documents among a large related document collection so that the you are testing whether the retrieval system somehow fetches these two documents, but also the reasoning system goes and um, synthesizes the new knowledge from the two documents. One optional thing is that the related document collection is also collected synthetically. Uh, this is done because A, you don't know whether there is other emergent knowledge that's coming from the large uh, uh, documents. So an example here would be this is what we are expecting a deep research system to do. and it's called lateral thinking. So, for example, you have these images, and then you have to connect to a concept in machine learning. Um, so here, I can tell you the answer in the interest of time. This is Adam Sandler. So that Adam, it's an optimizer algorithm. Lion is an optimizer algorithm. This is Richard M. Stallman, and Richard M. Stallman initials are RMS, which is another optimizer algorithm. Ada Lovelace, Ada Grad, etc. And this is Adam Sandler in the movie Click. So that would be Adam with Wade TK or Adam W. Uh, so if you ask GPT-5, it tries to it gets it wrong, and as of right now, you can see that models are pretty bad at things where you have to combine several different pieces of information, and then there is something emergent that comes from combining all of them. So the other strategy that I used is to use Wikipedia as a sole collection, and now use Wikipedia as the test set, and then find Wikipedia pages again that have where if you combine two documents, then you get some new synthesized knowledge. So, for example, Gandhi and the Eiffel Tower. So there is a Wikipedia page of Eiffel Tower, and then a Wikipedia page of Mahatma Gandhi, and then you are also fed the quotes by Gandhi about the Eiffel Tower. And then the question here is, was Gandhi in Paris during the inauguration of the Eiffel Tower? Fun fact, yes, he was. He was a international student in the UK when the Eiffel Tower was inaugurated in Paris at the Paris Expo, and he went to Paris to see it, and he wrote about it. But the idea is that you won't be able to answer this question just by looking at a singular Wikipedia page alone. But by the combination of all of these, it gives you a pretty strong, especially the quotes by Gandhi. You can put together the pieces and figure out that, okay, Gandhi was in this geographical area during the inauguration of the Eiffel Tower, and it's reasonable that he might have been there at that point. And same with the other one where we tried using Wikipedia edit. And this one is like very um, very engineered, where we have these Wikipedia pages about football players, and we edit the documents locally to remove obvious clues, such as who played in a particular game. Uh, and then ask this question: did one player, Jibril Cisse, ever play against Public Cisse? And then it has to go through all the games that uh, he played, when he played, and see whether the without them being explicitly mentioned in the Wikipedia page, just by figuring out the trajectory of their careers and the tournaments they played and the leagues they were in, etc. So yeah, so that's another strategy that we used. And then you have to also do, in the interest of time, I'll stop here, but evaluation at the component level. So there is, you have to evaluate the retrieval systems, the report generation systems, the reasoning systems, and then also all these non-functional metrics like factuality, citability, non-repetitiveness, specificity, coherence, novelty, usefulness, structure, formatting, completeness, and precision. So for us, when we are doing the deep research evaluation, we have all of these as part of a rubric that some of them are manual, but some of them can be automated. Like for example, uh, the factuality checks are like semi-automated. The non-repetitiveness checks are kind of automated, and so on. Uh, Things like novelty, etc., can't be automated at this point, and needs a human to see whether something that the deep research system came out with is novel or not.
We have a question from Vanraj. Can we make sure we are pulling data from all the sources for a specific topic? This would be a very resource intensive operation.
That's a good question. So, what we have been doing is we are making the agentic search system know specifically what kind of data sources, what feature, what kind of information to a rough degree, so that for a given query, the system is not exactly doing a extensive search across the entire your data catalog, but it's actually using its knowledge of the data catalog to only search in uh, those repositories or those data sources that it thinks is likely to contain relevant information. And that's also where we can use like hyperparameters that control the uh, level of detail of search that one wants. You can tune it such that it's going it makes a very expansive search, or it searches only those uh, systems where it is confident that it would find some information there that is relevant to the query.
Okay. Thank you. Again, just a reminder, you cannot raise your hand. You need to go to the Q&A panel, check the 9 dots on your right, and enter in the Q&A. We have one more question. What about hallucinations with respect to the evaluation, as the lateral thinking and emergent knowledge could lead to this?
Yeah, that's a really good question. So one another big issue with the current systems, along with the context limitation, is hallucination, especially the reasoning models that we have to use in order to make deep research systems work. They are unfortunately also known to have higher hallucination rates than the base case. So that's where I think we need verification steps in the pipeline that try to look for factuality, try to use citability. So if you look at like the list of non-functional metrics that I posted, factuality and citability are set at the top, so that there is a verification step in embedded within each step in the workflow, so that everything that you do is cross-checked a little, and maybe like you can assign a confidence score saying, okay, this is likely to be factual, or this is the model is not that confident that it is, and so on. But yes, it's a very significant barrier as of today.
Okay, thank you. I do actually have a question just out of curiosity. If people are wanting to go into these type of architectural solutioning, what would be your recommendation just to start out so as not to get overwhelmed?
That's a good question. So I think there are some open source deep research frameworks that they can get started with. But personally, I think it's still good to build something from scratch, because building a 101 deep research system is not that hard if you know how to implement RAG, if you know to use reasoning models. You can build a rudimentary deep research system over the weekend, and then making it work and actually give you useful results. That's the different journey. But just getting it working and seeing the power of the base capabilities of the reasoning and retrieval models is very interesting, and I think it already gives you a lot of um, food for thought. Yeah.
Okay. Any other questions? I guess, Suhas, if people want to connect with you, want to learn more, how can they connect and reach out just to understand and maximize the learnings that you've shared?
Yeah, so you can contact me on either LinkedIn or X, and I also have a Substack. I haven't been keeping the Substack very active, but I think, posting more stuff here, including on deep research.